Right. You're missing me. That's required in the
Oh, no.
if you don't have you missing me in there, it's a -10. You know. Life-giving juice.
If I had more time, I really wanted to do like different like 50 messages.
Have you ever played a mud before?
What?
Have you ever played an actual mud before, a text-based game like this?
Yeah.
So it's really funny how there's no graphics, but you actually get so used to where things are on the screen that it becomes way more, I don't know, like a better game than the games that are actually out there today, because your imagination's filling in all the gaps.
It's funny though, because I like those, but if you play older ones, it's like pick up torch. What's torch?
Oh,
Use hand.
Yeah.
You were lacking hand.
but once you get into it enough, then you start memorizing the stuff. And there's like, you want to go to your hunting grounds, you just put, north, 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 west, 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 north, east, down, then you're like, but you're just doing that super fast because you just know exactly where to go. All right, so let's look at this homework assignment. All right, so see, I write the homework down somewhere.
Yeah.
All right. All right, so we're rating a death match. We have 2 players. A player has a random number of hit points between 10 and 25. A player has a random armor class. So, okay, so 2 players. Each player has 2 pieces of information associated with them, right? So let's start with that. So we're going to remember a bunch of crap. Now, what we're hoping to get out of this, so we're starting to transition towards object-oriented programming. We're supposed to think that what we're writing here is a little bit frustrating, because there's so many just variables floating around. It's hard to keep track of what's what. So we're going to do a lot of it with naming conventions and things like that. So let me gut most of this. All right, we already have a roll function. Let's use the roll function that we already have. All right, so we're going to create a int. We'll call this P1 hit points, and player 1's hit points. What are the hit points for a player between 10 and 25? So I can roll a D15 and add 10 to it. Add 9 to it. No, D15 will give me a 1 to a 15.
You want to include 16. You want to include 10.
Oh, or I could just add 9. We can add 9 to it. All right, so we do 16 and add 10. Fine. All right, so we'll come back here. We're gonna do roll 16 and then add 10 to whatever that gets me. So that will give me some number between 1 and 16. And then, well, actually, that's not right. It's 15.
Yeah. No. It should be 16 plus 9.
Yeah.
Oh, yeah, I got it. There we go. So that'll give me 10 to 25. So this would be a number between 1 and 16. So if it's a 1, I add 9, that's a 10. If it's a 16, I add 9, it's a 25. It's ranging between 10 and 25. All right, then we have int P1 armor class. Armor class was what range? 8 and 16. Okay, so we're gonna roll a D9 and then add a 1 give it to an 8 is +7. That, so it'll give me the right range. Go ahead.
So the lowest it would be.
No, it wouldn't. because roll 16 will give us a 1 through 16 because we're emulating dice rolls. We're adding 1 to it in here. We're using the function that we wrote that emulates rolling a dice. So if I say roll a 16-sided dice, it's going to give me a value between 1 and 16, not 0 and 15, because of how we wrote this function. Rand mod sides would give me a value of 0 to sides minus 1. But I'm adding 1 to it inside of my function, which is why we're having to manipulate it. Make sense? All right. So that gets me player 1's stuff. So I'll just copy that here. We'll paste in here. So now we'll have player 2's stuff. All right. So we have player 1, player 1, player 2, player 2. So we have all the pieces of information. So now we want to have these guys fight each other until their hit points go down, until somebody's hit points is down to I guess a 0 or less. All right, so when they do damage, they're going to hit between 2 and 6. So we'll do the damage later. So the game has players flipping a coin to see who goes first. So we're going to first flip the coin. So that's going to roll a D2. Okay, or we can roll a D100, and anything less than 50 or less is one person. So you can kind of decide how you want to do it. All right, so we'll say int coin is equal to roll a 2-sided die, right? So this is going to give me a number either 1 or 2. All right, so we can ask the question, if it's a 1, player 1 goes first. If it's a 2, player 2 goes first. Something like that. All right. So we're going to have a loop that's going to go through until somebody actually dies. So we have our coin flip. Why don't we go ahead, we're going to say, for right now, since I don't know what Boolean expression we're going to put in there yet, I'm just going to throw a while true. Keep spinning forever. We'll figure out when it should stop. I might go and update that later on. But we'll leave it like that for now. So we're going to fight until somebody drops. All right. So now we want to ask the question. So if, and we're going to do this in a more obvious, direct way, and then we can clean it up afterwards because we're going to do it in a better way here in a little bit. So we'll say if coin is equal to a 1, then we're going to go ahead and assume it's player 1's turn. So player 1 is going to try to attack player 2. Player 1 will try to attack player 2. Else, player 2 will try to attack player 1. Like that, right? Now, regardless what happens, we need to make sure that if coin was a 1, we need to flip it to, let's just say, a 2 for the next time through. So it's the other player's turn. So if player 1 just went, we'll say coin is equal to 2. And you could have done this with a Boolean if just want to do true or false or something like that. Otherwise, if player 2 just went, the next time through, coin will be equal to 1. So we'll start it off with a random coin flip where it's either a 1 or a 2. And then from that point forward, after player 1 tries to go, he'll flip the coin over to the other side. So that the next time through the loop, it'll be the next guy's turn, who will flip it over to the other side. So the next time through the loop, it'll be this guy's turn, so on and so forth. Good.
I did it a little more complicated with that. So I did the dice roll and I used 0 and 1, so you didn't use the dice.
That's fine.
Then I did, if mod 2 equals 0, that was player 1 turn, otherwise player 2.
Yeah, that's fine. So player 1 goes on even turns, player 2 goes on odd turns. That's fine. Yeah. It's all accomplishing the same stuff. Okay, I'm just mimicking the idea that we flipped a coin and a coin has 2 sides, but all this is just, ultimately we want this guy to go, and the next time through we want this guy to go, and the next time through we want this guy to go. So we've created a mechanism that'll keep flipping back and forth now. Okay, so what does it mean for player 1 to try to attack player 2? Well, it means that player one's gonna make an attack roll, right, to try to clear their armor class. All right, so we can go ahead and say attack roll, and an attack roll is a d20. So we're gonna do a roll 20. All right, so now we have our attack roll there. And then we ask the question, if attack roll is greater than or equal to, this is player one attacking player two. So if attack roll is greater than or equal to player two's AC, the guy you're swinging at's armor class, right? So if attack roll is greater than or equal to player two's armor class, we hit the target. Now do damage. All right, so now we're going to roll our damage. And I realize I'm writing the variables inside of here. We can clean it up later on, but I just want to keep it clean as we're going through. So we're going to say int damage. And this guy's going to be damage is between 2 and 6, right? All right, so what are we going to roll? If I roll a 1, I wanted to get it to a 2, so I'm going to add 1 to whatever it is. And if I roll a 5, I want to get it to a 6, so I'm going to roll a d5. So we'll say roll a d5 and add 1 to whatever comes out of there. That'll give me between 2 and 6. All right. Now you could have done your random number generator more directly. I'm just basically saying I have this generic die sitting here and I can instantaneously change the number of sides. I'm just using that little tool and then manipulating the output to give me the number range that I want. You could have done stuff with mods and things like that if you wanted to, no problem. Go ahead.
Order of operations, does it solve left to right?
Does who?
This C++.
Well, it's going to use normal order of operations, but I'm not sure how that comes into play here. Yeah, because this is going to just be a number. So yeah, it's left to right following normal order of operations, just like any other math thing. You could use parentheses to, yeah, it's not different than math. Same as math. So multiplication, division would happen before addition, subtraction. Like this?
No, you did like +1 and then like time 1.
Oh. Yeah, correct. Yeah. So he's saying if you do that, this would be whatever the roll is +6 or +5, because 5 times 1 is 5. It will do the multiplication first and won't add 1 to it. So yeah, it's just standard math. All right, so there's our damage. So we did hit. We calculated our damage. What do we do to our damage? We subtract it from our opponent's hit points. So we're going to go ahead and say, who's our opponent here? It's player 2. So player 2's hit points is going to be equal to whatever their hit points currently is equal to minus the damage we just did. All right, makes sense? All right, well now we have to ask, did player 2 die? You know, because the only person who could have died this time through, since we don't have like, you know, ultimate miss rules, like with a rolling a 1 and cutting your own leg off or something. The only person who could have died in this particular round is player 2, the recipient of the axe swing or whatever the weapon was, right? So now we're going to ask a question. If player 2's hit points is less than or equal to a 0 after we've applied that damage, player 2's dead, right? So we can do something like C out, player 1 wins, something like that. And for right now, we're going to go ahead and leave it where this loop is going to keep going, and we're just going to we're going to have 2 corpses beating on each other for a little bit. Okay, so we'll figure out how to escape here soon. Go ahead.
Put an else if in the bottom, so that only one runs, so else if, and then.
You want me to put it right here? I mean, the short answer to your question is you're asking, can I have this in another place? The answer is yes, I could, as long as I know whose hit points I'm checking. But the only place it really makes sense to ask this question is if this dude just took some damage, was it enough damage to kill him?
Yeah.
His player one state.
Okay, you just did a catch-all question, like, did somebody die this time around? Yeah, and that's fine. But what I'm doing here is I'm saying the only way somebody died in this particular run through the loop is, since player one is attacking player two, the only person who could have died is player two. And he could have only died if he got hit. So I'm asking it situationally. I'm not asking the question every single time through the loop. I'm saying if contact was made, I'm going to see if the dude who just got hit is okay. If contact was never made, he's still kicking. Why ask the question? It's not wrong to ask the question. You know, that's like, you know, the parent keeps running up. Are you okay? You know, the guy just swung and whiffed, missed me, you know, but you know, certainly a lot of these things you can put in different places, ask the questions differently. I'm trying to write it very verbosely for I'm kind of almost trying to think like you probably would have thought as you went through this, not trying to solve this in a hugely optimized way, just thinking about it like, okay, here's the series of instructions I need to do to go through this problem sequentially. All right. So if it was player one's turn, that's what coin is equal to 1 means. Then player one will roll their attack roll. They'll check their attack roll against player two's armor class. If their attack roll was strong enough, they'll generate the damage they're going to do randomly. Then we'll subtract that amount of damage from player two's hit points. And then we're going to ask player two, are you still alive? If their hit points is less than or equal to 0, we're going to yell player 1. Now, from this point forward, we don't need to fight anymore, right? Player one's dancing over the dead body and, you know, doing what don't they do that in that game? What's the game? The survival game that all the kids play. Fortnite. Isn't that like the thing, like they dance on your corpse, right? It's like a thing to taunt you. You got like an 8-year-old who just killed you because you couldn't figure out how to like mess with the weapon you were supposed to have. I suck at those games. All right, so we're going to need to figure out. So we are done fighting. How do we get out? Now, we have multiple ways we can do this. What's something that we've covered in class? Do we need to do anything else after somebody's won and we've reported the winner? Okay, so based on what we've learned in class, how can I make the fight end? Good. Yeah, I could just say return. Tactically, main wants you to return an int, so you can have it return that int, but you don't need to. I can just come in here and say return. What does return do? Return makes a function immediately end. Okay. And we have not talked about break in here, correct? Okay, good. So we'll talk about that today. So return will make our program end. They fought to the death. Somebody died. We announced the one who won. Program's over. So we'll return. All programs begin and end with main. What does return do? It makes a function immediately end. What function are we currently in? We're currently in main. So we'll make main end, which makes the program end, since all programs begin and end with main. Okay, so that's what we do when it's player one's turn. And then if we're still alive, when we get down to here, even if we got in here, as long as we didn't return yet, that is, player two did not die on the last swing, you know, he was tough. Then we'll go ahead and flip the coin over so that the next time through his loop, the other guy will try to attack. So we're going to do pretty similar stuff. In fact, let me just steal. I'll steal this and we'll modify it. So if it's player two's turn, we'll generate an attack roll. We're going to check that attack roll against player one's armor class. If it hits, we'll generate our damage. We'll subtract from player one's hit points the amount of damage that was just done. We'll ask a question about player one's hit points and say, hey, is player one's hit points less than or equal to 0? If it is, that means player two won. And that means we're done fighting. So we'll hit return, program's over. All right, make some sense? So let's go ahead and run this dude. I didn't do who? Oh, it does want me to, since I'm returning, it does want me to return a value. So I can do the return 0 or whatever, like we had before. I have the while loop in there. Oh, right. I haven't made a change to it, but right now we don't need to make a change to it. So that particular time, player 2-1. Now, why is it they don't have to make a change to it? Our while loop, while true, how long will this loop spin for? Forever, right? Is this a Boolean expression? What's a Boolean expression? Any expression that boils down to a single value of true or false. Is that a Boolean expression? It is. Now, is that, remind me, what does the return statement do again? Makes a program immediately end, right? So didn't matter if I was trapped in this infinite loop, I killed the program from inside by hitting return. Make sense? Now, you could have written it. So here we have player 2 win that time. We'll just run it a couple times. Player 1-1, player 1-1. Now we're not giving any commentary along the way of how hard somebody got hit and stuff. We can certainly add that stuff in. So we can do like a see out. Player 1 hits player 2 for damage. Something like that. And we could put the same thing in our other guy here. Player 2 hits player 1 for damage. Run this again. We'll see the beat down. And if we wanted to, we can have a little information on the side of the current status of our two players.
Yeah, I feel like see out.
Yeah.
So we could do something like this where we can say, well, yeah, I'm not going to add too much more commentary here. We can say, here's player 1's hit points, here's player 2 hit points, and we can just watch it kind of decline and see who's about to die and that kind of stuff. You can make your output look however you want. All right, so for right now, we're utilizing this knowledge that the return statement makes a function immediately end. We are currently inside the main function. So when I say return, the main function ends. Doesn't matter that we're stuck inside of a while loop that says while true. All right, now having said that, we don't have to use the return statement trick to pull this off. You would instead say, okay, well, what can I do to this loop here to make sure that I have the ability to end it at some point? All sorts of things you could do. You could do something like int. Actually, let's do this. Bool like that, capital bool. Bool should loop. We'll start that off at true. So we can say while should loop, or you can, if you feel better about it, you can say while should loop is equal to true. This is redundant because if should loop is true, true is equal to true. If it's false, false is not equal to true. So you could just say while should loop. But you can say something like this if it makes you feel better, asking, is this variable equivalent to true? We know it will be the first time because we set it up as true to begin with. And then what we can do here is whenever we want this program to end, rather than return, we can set should loop equal to false. So the next time through the loop, it trips up. Because by setting should loop to false here, when it spins back up and asks the question, is should loop equal to true? It's not. We set it to false, which will make the next time through the loop end. Same thing here. Oh, it is bool, right, for C++? Yeah, there we go. All right, so now we are causing our for loop to end when we want it to end. As soon as we know it needs to die, it'll die. Go ahead.
Why would you not just put the conditionals or this statements into the line?
You could, but then you are asking that somebody die every single time, which isn't a problem. You could say, hey, look, if somebody's dead, effectively what he wants to do is something like this. You want to say, we're going to keep looping as long as both players are alive, right? That's, yeah. So, well, yeah, but by saying both players are alive, we mean their hit points are greater than 0. So while P1's hit points is greater than 0 and P2's hit points is greater than 0, ultimately it does the same thing, right? We're not using the should loop thing anymore, but as long as both of these guys are alive, let's keep swinging. You can certainly do that too. Yep, accomplishes the same thing.
I was gonna say, I did that, and then after the loop broke, then would see out whichever one won.
And that's fine too. Yeah, I mean, we're being pretty redundant here, partly because we don't have objects. If we had objects, we can make this a little bit cleaner, and that's the direction we're sliding with this. Okay. So if in your head you're saying, hey, I have a solution that also gave me a similar output, that's fine. There's a whole bunch. I mean, in the last minute, we saw like what, 3 or 4 ways of killing off our while loop. But if we spend another 10 minutes, we can do all sorts of weird, freaky deaky stuff and get the while loop to die one way or another. Okay. So there isn't a correct answer, but there's a series of, hey, this is, your program's personality or whatever. So I would say that what we have written right here, I don't dislike this because it's straightforward. It's saying if both dudes are alive, fight. So that's a straightforward statement. Or maybe the thing about the should loop thingy, maybe a lot of older programs, you'll see this variable called like flag. They'll call it flag. So a loop keeps going as long as the flag is true. And as soon as you want the loop to end, you just flip the flag to false. And then, the next time through it checks it, fails the Boolean statement and keeps going. So it's a way of like short circuiting a loop, because in this case, we don't know how many times this loop needs to run before somebody's dead, right? Maybe bad programming practice, you could kind of do something like, well, surely someone will die in less than 1 million rounds. You write a big old for loop, and then at the end, this guy's just getting just ripped on. You're showing, they're at negative 62,000 hit points. Like, why'd you do this? Like, you couldn't stop. Exactly.
Both, yeah. Whichever one was.
Oh yeah, but now we're Walking Dead level stuff. We have animated corpses, and obviously they get a -2 to all attack rolls, so it's going to slow way down. Yeah. Somebody loses an arm, the other one picks up the arm, and now that's their new weapon. Okay, so now they get +3 whip damage. So we can go all sorts of directions with this. My teacher was talking about how I guess you get bonus whip damage from a severed human arm. Seemed like a really weird conversation for a computer science class. Yeah, well, they do call it a liberal arts school, so we're getting a little biology in there. All right. Make reasonable sense. This is an approach to your assignment. hopefully what we're seeing here is there's gonna, it feels verbose. Like it feels like we're doing a lot of very mechanical things, you know, like you hit that switch and hit this switch. And yeah, it works, but we can pretty quickly imagine. I mean, this isn't a real complex program we're writing here, right? We can pretty quickly imagine that we're going to become more and more error prone if we're juggling 30 or 40 variables at once, making sure we incremented or decremented the right dude's hit points and whatever, right? So we can kind of see the writing on the wall that this becomes problematic for us, and maybe having some tools might make life a little easier. Go ahead.
So I actually restarted, I restarted 3 times. So the first time I had, like if coin, like the stuff in that,
Yeah.
like all the damage stuff, I had that. I had to rewrite it every single time, and I had like 3 separate hits that we completed, but I was all other parts of it. My wild set was off. And then what I did the next time that I made a function this time, so I would do like function player 1 turn, and then pass in the variables that we need as parameters, I think, and like present it that way.
Yeah. So you wrote some functions that took some of these pieces out, right?
Yeah.
Okay. And we could do that. And a function is going to make a whole lot more sense once we have the ability to kind of say, here is player 1 and here is player 2, as opposed to saying, here's player 1's hit points, here's player 1's armor class, here's player 2's hit points, here's player 2's armor class. And keep in mind, that's us keeping it simple, right? Once we can start passing our players around as ultimately objects, just like, you know, I use, well, my phone's in my pocket here. This is a coffee mug object. We know there's stuff in here, right? We know there's somebody built this. It's got whatever insulated, blah, blah, blah. Who knows how it works? But, you know, if I wanted to close it and then throw it at somebody, you're getting not just, I mean, you're getting all the stuff that comes with this guy, right? Okay, so objects are how we solve problems in real life. And if we can start angling towards that in coding, that's going to make things beneficial for us. And this relatively simple project here is starting to show how, you know, maybe I should clean up my room a little more often. I need to have a couple of tools for organizing my my code and my ideas, because pretty quickly this is either going to become correct, what is usually called spaghetti code, where you just got stuff, you know, plastered all over the place. It technically works, right? You know, you peel open, some prototype for a smartphone. There's 4 zillion wires, and I mean, it's all functioning, but that is just a mess, right? You don't know where to, you get to fix. You cut the wrong wires, everything breaks, right? So we want to have tools that allow us to better organize this stuff. So let's start looking at some options there. Now we're going to take an intermediate step. We're not going to immediately go to objects. We're going to go to something called a struct. All right. So a struct is short for data structure that is built for holding a collection of name value pairs. So that's just a collection of variables, right? Under a single variable name. All right, now before I forget, let me actually, let me just do this. I put the current deathmatch code in Slack, because as we get to your homework assignment for today, it's going to be to update whether you start with mine or start with yours as a baseline. Update it using structs instead of the way we've written it this time. Okay. And the next time we'll upgrade it again to objects. All right, so this is what a struct is. if you've had some other programming languages before, like Python, and several of you got yelled at on your exam because you've had Python before, and rather than writing your code in the exam in C++, you wrote it in Python. At the end of the day, I don't care. But if you're not actually learning the new language that's going to teach you stuff about future languages you're going to learn, and you're just resting on your Python knowledge, promise you you're going to fall off the cliff sooner rather than later. All right. But in Python, there's a thing called a dictionary. And dictionaries kind of work like structs, but I say kind of work like structs. And that's something we're going to be talking about today with pass by value versus pass by address. So that'll make sense when we get to it. And even if you've used dictionaries, you may not have covered this concept of them, but you'll know what I'm talking about here in a few minutes. All right, so we can do something like we can say we're going to create a variable of type struct. Maybe we have a struct player. And our struct player has an int hit points and an int armor class. Something like that. Okay. And now we can create variables of struct player. So I can say struct player P1, struct player P2. And I can say things like P1 dot hit points is equal to 16, P1 dot armor class is equal to 10, P2 dot hit points is equal to 12, P2 dot armor class is equal to 8, things like that. So now we can access individual aspects of that player by using dot notation. So let's come into our code here. Code. All right. So what I'm going to do here is we're going to go ahead and build ourselves a struct up here. And then we're going to mess with the struct a little bit. We're not going to incorporate it into our code because that's something you're going to do for your assignment. But we're going to start talking about structs in general, and then this idea of pass by value versus pass by reference or pass by address. So I'm going to say we're going to have a struct, and we'll call this guy a player. So I'm creating my own data type here. I'm creating a variable of type player, and players have pieces associated with them. So I'm going to say int HP is one thing that players have associated with them, and int AC is another thing that players have associated with them. Go ahead.
Purposely outside of main.
Yes. I'm effectively prototyping this new variable type so that I can use it from this point forward. But keep in mind that if you do have, this then actually becomes kind of interesting, because if you have structs built in terms of other structs, now you're right back to that chicken or the egg problem. So that's kind of where header files can come in. And yeah, this guy. Yeah, it's part of the syntax because this is all statements in C++ end in a semicolon. I guess the stupider thing would be to say unless they don't. But okay, block structures are the one thing that don't, but then that breaks this because this one does. Structs are different. It's good. But if you forget it, C++ is happy to sit there and scream at you. Error expected semicolon after struct definition. And actually, with that being said, it's not illegal. I can put, I believe it won't scream at me if I put if I had an else associated with that, it would be a problem. But yeah, I could put semicolons at the end of if statements. But if I had an else, it would that semicolon says this statement is done. So typically we would not put that there, but it's allowed for us not to put it there because of how this language is built. And when you take the 470 class and we implement a language that has for loops in that, and if statements in it, things like that, it'll make sense. We have a formal language that the programming language follows, and in our design, we decide when a statement ends, because the compiler that's going to read this, or the interpreter that's going to read this, needs to know when you're done with one thing and about to start the next thing. There has to be some sort of separator. Python doesn't have these things because Python uses indentation to decide when something starts, when something ends, that kind of stuff. All right, so we've created a data type called player. We don't have a variable of player yet. We've just created the blueprint for building a player. All right, so now what I can do is I can, in fact, why don't we create a couple of players here? So I'll, you know what? I'm not going to change that. I don't want you to do that. So I'm going to go ahead and I'm going to create a player. I'm going to say struct player P1. So now I've defined a variable named P1 that's equal to, that's of type struct player. So now I can say P1 dot HP is equal to 17. P1 dot AC is equal to 10, for example. So now I've given two pieces of information and they're housed inside of a single variable called P1. Go ahead. You would be initializing those, yeah. Okay, but my focus right now isn't on making the game work with these. It's to focus on passing structs to functions and whether things that get passed to functions are passed by value or by address, which we'll talk about. All right, so I'm going to create a function here called display player. And it's going to take in as a parameter a variable named P that is of type struct player. So whenever you're working with structs, you have to use the word struct in front of it. Okay, so we know that player is of type struct, but we have to say, I want you to deal with, this is taking in a variable of type struct player. So there's my prototype for that function. Go ahead and write this down here. And I'm going to go ahead and just print out the aspects of that guy. So I'm going to say cout player. You want to make it look fancy? We can do we just upgraded to high definition graphics. And then we can do cout HP P.HP. Cout AC P.AC. All right, so now I have a function that I can pass a single player to, and it will display the components of that player, showing us that we can store stuff inside of our player structs. That's the purpose of a struct. I can store stuff inside of this package and then just pass the package around. Okay. But the important thing, the important limitation we want to have in our head right now is that structs do not let us store functions. It only lets us store information. Now, that's a tiny lie, because there are some things you can do with function pointers to sort of kind of pull off functions in there. But that's kind of a hack that was being done with procedural languages like C as we really got up to the point where we just needed something better, and that's where object-oriented languages were born. So what we're experiencing right now is really like, hey, I need something else that allows me to solve problems without being so error prone. Like we can kind of see ourselves starting to get here with 4,000 variables. And then having to write functions that take 9 variables as parameters, that kind of stuff. But we're still, as a C programmer back in the 70s, we're still kind of able to pull it off with this and then just write functions that operate on structs. So here's a function that takes a struct as a parameter, and I'm just pulling out some of the pieces of information from that struct. I just happen to only be storing 2 pieces of information in this struct, but you can store 200 things in there if you want. All right. So what I'm going to do for the moment, especially since I already gave you the code on Slack, I'm just going to dump like a lot of this stuff so I can bring the focus into what I want to talk about here. All right. Go ahead. Because it's a known function call. Online GDB just knew that it's something built into our language. So it highlighted it, said, here's a function that I recognize. Yeah, no, it's not something special from our perspective. It's, if you were doing this in Notepad, nothing's lighting up pretty. That's one of the things where some text editors, Visual Studio Code, kind of color highlight stuff for you, things like that. A lot of the programming based text editors do that stuff for you to make your life a little easier. That's kind of the reason why they have you choose your language, so they can try to do the best job of that for you. All right. So now what we want to do is we want to go ahead and call our function, and this function does not return anything. Instead, it takes a parameter and does something with that parameter. All right, so I'm going to call this function display player. Display player is expecting me to pass it a player struct. And I have a player struct here named P1. Okay. So when I call that, we expect P1 to pass into display player as a parameter, and it's going to print out player, then that person's hit points and armor class. So there's our player, hit points, armor class. Make sense? All right. So now we're going to write another function. We're going to say change value. Actually, it's called change player. We'll have this guy take in a struct player as a parameter as well. And all he's going to do is he's going to change that player's hit points to -5. Just for no good reason other than this example. So we have a function that takes in a struct player, and he's going to modify one of the components of that player. All right. Now we'll prove to ourselves that that modification has happened by displaying that player. Now we're already seeing benefits of structs here, because before we were thinking, oh, it's going to be a headache to display the various components of my player. Now we wrote a single function that can display your components of your player, and we just have to pass it the struct. Here's everything about a player. Deal with it. Okay. So we'll go ahead and display our player here, showing us that that value's been changed. So after I display the player initially, I'll go ahead and call change player, passing it P1, and we'll see that its hit points have changed. So there's our original player with hit point 17, armor class 10. And here's our updated player whose hit points are now -5. and armor class is 10. Okay. Now, after that call to change player, I'm going to display the player again. So the question is what will the value of hit points be after change player returns and we're back to main, looking at our player? Will it still be the modified -5, or will it revert to the original value of 17? And I'm not necessarily asking you to know the answer. I'm asking you to consider how you would expect it to work. All right. So the model here is that I have a thing here. I hold it up. This is the current value of this. Okay. Then I toss it to him and he makes a change and says, here's the change. Okay. Now it's done. I have control of it again, let's say. I never actually lost control. I gave him access to it, let's say. But now I hold it up and we want to know, did his modification get back to me, or, which is sometimes called side effect in a computer program, or did it get reset to my original value? What's your prediction? Okay, some people think it's changed. Some people think it is the original. It is the original. All right, so here's our original. Here it is after it's changed, but inside the scope of where it was changed. So that second print is this guy right here, which is local in scope to this version of P. So what's happening here is we have something called pass by value. And we'll go down that path. We have something called pass by value. This is when a variable is sent as a parameter to a function, and the variable, let's say, and a copy of the variable is sent rather than the address of where the variable lives. Okay. See, did we look at arrays in here yet? We have not looked at arrays, right? Okay.
Saying that there's two different things being sent, or you just think
One thing, just so if we go back to our example here, when I threw him my object. So pay attention here. So I have my player object here, and I just showed everybody the answer. When I threw it to him, the function call, he got a copy of it. I still had my original with all the original values. He got a duplicate of it. He started making changes to his duplicate. And sure, when he holds it up, it's got the changes. But when he died, I don't have a modified version of what he was working on. Instead, I have my original that had all the original values. Because when I called it, he got a copy. As sort of. Now, just to kind of go back a little bit, and let's say, well, what happens if I do this with like integers? So if I have a void change int, and this guy takes in an int a as a parameter. And I write this guy, and he's going to say a is equal to 15. We'll do a C out a and L. Then inside here, I'll say int val is equal to 2, C out val. Actually, let's go ahead and call it a just to really drive home this idea of scope. Then I'll call change int. I'll pass it a. And then I'll C out a again. So now instead of dealing with structs, which maybe felt like they were these special animals, okay, now I'm dealing with just a normal plain Jane integer, which seems very primitive to us, pun intended. Those are one of the primitive type variables in C. All right, so now I defined an int a, I display it. This is going to show us a 2. No surprises there, right? All right, then I pass it in to change int. Change int is expecting an integer to come in. I just happen to name it a. So, but these are 2 separate scopes of a. It changes a to 15. When it displays it, it's going to display a 15, right? But then when we come back here, after change int has returned, it's going to show a 2 again. Because when I passed it to change int, I passed it by value. I sent it a copy of the value that was stored in a. So the default behavior of working with primitive types like int, char, bytes, floats, shorts, booleans, doubles, the default behavior for all of that is when you pass one of those to a function, it is passed by value. That is a copy of it is sent, not access to the original. So any changes you make to it inside of that function will be temporary changes. Now, given that knowledge, if I really want to get my modification back out of the function, our solution to that right now is to return it. So I can change this guy to return an int. All right, now I make my change in here, prove I made my change. Then I'm going to go ahead and return that value of a. Okay. Now, if I run this program right now, it's still not going to have any difference. It's still going to be a 2, then a 15, then a 2 again. Why? Because even though change int did return the updated value of a, I didn't do anything with it here. I can say a is equal to that, changing the value of a to whatever this dude spit out. And then I can get my 2, 15, 15. All right, so whenever we're dealing with primitive types, whenever we're dealing with the types we've been introduced to so far, with the exception of strings, just treat them as special cases for right now. We are passing by value. We're working with a copy. Sometimes that's what we want. We want to be able to manipulate a variable inside of a function and not have to worry about what global damage we've done, right? But sometimes we want to do something to it and have those impact, that effect be a global impact, have a global impact to it. All right. So hitting the brakes for a second, we're going to say, so for right now, let's say this is the default behavior for all primitive types as well as structs. For those of you who have done Python before, the default behavior for dictionaries is not passed by value. It's passed by reference, passed by memory. We're going to be talking about that coming up soon, if not by the end of today, next class. But the default behavior for dictionaries is passed by address, not passed by value. So if we had made changes to a struct, a dictionary in Python, those changes would be felt elsewhere. Okay, where in C, C++, structs are passed by value. So they, even though they seem like they're solving the same problem, they are solving different problems. So they don't behave the same when you pass them to functions. And what does that mean for you, the programmer? It means be aware of how your variables are being passed to a function, and whether or not you should make changes to them. Because if you make changes to them and it's passed by address and you didn't solve the problem as if it was being passed by address, now all of a sudden you have modified stuff floating around in the rest of your program that might not be what you expect. So let's look at arrays for the moment, though, I can give you your next homework assignment. Update your deathmatch code. And I can say C Slack for a starting point if you would like to use structs to hold information about the players rather than multiple variables. Okay, so just a little upgrade. You're going to use structs instead of those. So in our example, instead of having 4 individual variables, we're going to have 2 variables, a struct for player 1 and a struct for player 2, but that's all of type player struct. And then we'll set the hit points and AC for each of those and then do all the logic using those structs. All right, so just a little modification to it. So now we're going to start talking about arrays. So an array is a collection of like values stored under a single variable name. Now, in some ways, we've already been exposed to the concept of an array through a string. Strings are collections of chars, right? So, you know, when you say hello world, that's just a collection of a whole bunch of different character types. And we're storing it under a single variable. String s equals hello world. S is effectively a collection of chars. We call them strings, and we're using the new style of strings with C++ because it makes life friendlier, and the strings then behave like the strings of other programming languages. I'm going to purposely use old style arrays for this next lesson to drive the point home about memory, which is what we're going to be focusing on. We're starting to talk about this concept called pointers, which a lot of folks kind of get freaked out about. All right, so let me just bring up, well, let's just start off with the starting point here. So if I want to define an array that holds 5 integers, I could say int AR 5. So now I have a variable named AR, and it's built to hold 5 things. And we're going to look at another way of doing it. We're going to see what the differences are here in a few minutes. All right, so what I'm going to do here is I'm going to go ahead and, well, I'll leave whatever. I'll leave that stuff in there for right now. All right, so I'm going to say int AR5. I'm going to say cout AR and L. And you're going to see that the value of AR is a memory address. Now, what does AR actually look like? AR holds 5 integers. These 5 integers are stored in what's called contiguous memory. Memory right next to each other in the computer. So we can think of this guy as looking like something like that. All right, and I'm actually, well, so and similar to strings. This is bucket 0, this is bucket 1, this is bucket 2, this is bucket 3, this is bucket 4. And just to show you the connection for this contiguous memory thing, let's assume in our example here, rather than this be this really scary number, that's a hexadecimal value, right? So some gigantic number. Remember I said that computer's memory, everything's on one big long street. All right, so this is some big number. I'm just going to pretend like it gave me the number 100. Fair enough? All right, so my array lives at memory address 100. Now, what kind of thing am I storing in my array? I'm storing integers. How big is an integer? 32 bits or 4 bytes. Okay, so the very first integer, if it lives at memory address 100, the second one will be a memory address 104, 108, 112, 116. Contiguous memory, memory that lives right next to each other in your computer's memory. So what we actually get, what displayed here, is what's called the base address of the array. That's where the array starts in memory. And since we know that arrays are built in contiguous memory, as long as we can get to the bottom or to the beginning of it, if I need to get to bucket 3, I can take 3 int size steps through memory to get to the third variable, third value. All right, so these guys are stored in contiguous memory. So kind of to show you that, let me just put some numbers in here. So let's just do, that's a 6, that's a 2, that's a 14, that's a 9, that's a -3. I just haphazardly stored some stuff in our array. All right, and if we want to do that in code, I would do AR, let's say 6214. AR at bucket 0 is equal to 6. Bucket 1 is equal to 2. Bucket 3 is equal to 14. 9 and -3. Was testing you whether or not I was able to count between 0 and 4, and the answer was no, and you all failed. was seeing if somebody would speak up or say, I don't think he knows how to count. But he did know how much additional whip damage a severed arm would cause. We all have expertise in something. That's what it comes down to. All right, so this would be the syntax for accomplishing what I just accomplished here. All right, so just to wrap things up for today, to give us a good stopping point for next time, if I say something like A at bucket 3, like that, that's the same thing as saying, we called it AR, right? AR at bucket 3 is the same thing of going to the base address of AR and adding to it 3 times the size of an int. So that is going to 100 plus 3 times 4 is 12. So 112, which is the memory address of bucket 3. So by arrays living in contiguous memory, it allows us to calculate the location of an individual bucket of that array in memory, as long as we know where that array starts. And the punchline there is that makes arrays fast. Okay. All right. So I'll put the homework assignment up for next class. which does not deal with arrays. Next class just has you converting our current code to structs. We're going to talk about arrays next class, and we're going to see how they are passed by address. Then we're going to talk about syntax for pointers, and then we'll get into object types. All right, remember, CS get together is at noon across the hall in S118. It lasts like an hour. Yeah, but they'll probably have some of they have like a game at the beginning that you play, and that gets you if you win that, you get the first dibs on the better prizes, like the expensive stuff. I don't know what the really good stuff is this time, but you shouldn't have a class at noon. Noon's lunch hour. Oh, really? Oh, weird class. What's up? Oh, let me actually stop the recording just so I don't forget.
I don't know. Be able to answer this question.